Alright guys, had to go shut the door so the kids didn't come in, but I just want to read through the natural gas reading and questions with you really quickly because I know there's some terms on here that I just probably need to explain as we go through. So you're going to read this following, answer the questions that are done. Make sure you're using complete thoughts and sentences. So use the question and the answer. I know you've heard that a million times in your 6 years of schooling, so it shouldn't be a shock. All right, the uses of natural gas. Just going to scroll through here and read this with you. The United States used about 30 trillion cubic feet, so that's what the TCF. Don't really need to worry about that number too much, but just know that that's a lot. The equivalent is 31 quadrillion BTUs, British thermal units, and 31% of the total U.S. primary energy consumption. So what is natural gas used for? Here it is right here. So natural gas used by U.S. consuming sectors by amount and share of the total U.S. natural gas consumption in 2018. So this is a year-old data, but it's about as new as we can get because they're still compiling it for 2019. So it's pretty good data, okay? And so if we look here, we have our electric power is 35%, industrial is 33%, residential is 17%, commercial is 12%, transportation is 3%. And so obviously we use natural gas mostly for electric power. And so when you take a look at that, it's pretty important to remember that electricity is natural gas. Industrial, lots of different applications there. And then residential is mainly two things, heating and then to heat our water for showers and stuff. Okay, excuse me, I gotta grab a Kleenex real quick. All right, sorry about that. So, many U.S. natural gas use is for heating and generating electricity, but some consuming sectors have other uses. So electric power sector used natural gas to generate electricity. In 2018, the electric power sector accounted for more than 35% of the U.S. total natural gas consumption. The natural gas was the source of about 29% of the U.S. electric power sector's primary energy consumption. So close to 30% of all the electricity we use comes from burning natural gas, and the natural gas heats water. That steam turns turbines, and the turbines turn into electricity. So that's kind of a simple process. I'll talk more about that in the Zoom class today. So U.S. or most electricity powered by the electric power sector is sold and used by other U.S. consuming sectors. So the electricity used is included in each of the sector's total energy consumption. So that electrical power is shown as being generated and then sold. Okay, and so the other consuming sectors also use natural gas to generate electricity, and they use nearly all of this electricity themselves. So when we look at industrial and residential and commercial, or sorry, industrial, commercial, they're creating electricity and then using it themselves for whatever purpose that is. Okay, the industrial section uses natural gas as a fuel process, heating and combined heat and power systems. Yeah. Oops, went too far. Let me go back up. Okay. All right. All right. So in combined heating and power systems, and used as raw material or feedstock to produce chemicals, fertilizer, and hydrogen. In 2018, the industrial sector accounted for about 33% of the total U.S. natural gas consumption. The natural gas was the source of about 32% of the U.S. industrial sector's total energy consumption. So it's used a lot. Okay. The residential sector uses natural gas to heat buildings and water and to cook and to dry clothes. About half of the homes in the United States uses natural gas for these purposes. So that's quite a bit. Okay. Most people in town have natural gas. People that live out of town use something that's a little bit different called LP or liquid propane. And so it's just pretty popular. It's used a lot, and the reason why it's used a lot is because it's fairly cheap and it's the cleanest of the fossil fuels. The residential accounted for about 17% of the U.S. total consumption, and natural gas was the source of about 24% of the U.S. residential sector's total energy consumption. The commercial sector uses natural gas to heat buildings and water and to operate refrigeration and cooling equipment, to cook, to dry clothes, and to provide outdoor lighting. Some consumers in the commercial sector also use natural gas as a fuel and combined heat and power source. In 2018, the commercial sector accounted for 12% of the U.S. Natural gas consumption. The natural gas was a source of about 19% of the U.S. commercial sector's total energy consumption, so quite a bit, right? 1 out of 5 um, energy used comes from natural gas. I guess I don't know really how to say that a little bit better, but about 1/5, right? Um, the transportation sector uses natural gas as a fuel to operate compressors that move natural gas through pipelines and has a vehicle full fuel in the form of compressed natural gas and liquefied natural gas. And so a lot of the buses are switched over to natural gas because it burns cleaner than diesel or gasoline in the big cities. Also, like forklifts and some of those other things that are used are using natural gas as well, or liquid propane. Nearly all vehicles that use natural gas as a fuel are in the government and private vehicle fleets. In 2018, transportation sector accounted for about 3% of total U.S. natural gas consumption. Natural gas was a source of about 3% of the U.S. transportation sector's total energy consumption in 2018, of which 95% for which was natural gas pipeline and distribution operations. Okay, so there's kind of the what it's each being used for, right? And so you can't even really see transportation. It's just this thin red line up here on the top. Okay, but electrical power is the biggest, the widest. Industrial, and then commercial. You can see commercial's gotten bigger since 1950, and residential is fairly consistent since the 70s. Um, there's more homes, there's more people, so we're probably using more, but the percentage is consistent. Okay, natural gas in the environment. Natural gas has many qualities that makes it efficient, relatively clean burning, and economical energy source. So it's cheap and it's relatively clean, meaning it's cleaner than the other fossil fuels, but it still is going to release some carbon. There's issues with that. And then so up here it says, however, the production and use of natural gas have some environmental and safety issues to consider. Obviously, it's explosive, so it's dangerous, but um, environmentally, it's the cleanest of the non-cleans. All right. And so let's read a little bit more about that. Natural gas is relatively clean burning fossil fuel. All right. So the burning natural gas for energy results in fewer emissions of nearly all types of air pollutants and carbon dioxide. And the burning coal or petroleum products can produce an equal amount of energy. About 117 pounds of carbon dioxide are produced per 1 million BTUs, the equivalent of natural gas compared to about 200 pounds of coal and 160 of distillate fuel oil. But there's a process to get it to distillate fuel oil, so that number is a little bit misleading. The clean burning properties of natural gas have contributed to increased natural gas use for electricity generation and for transportation fuel for fleet vehicles in the United States. And so that's what I was talking about. Even some of the oil filled pickups and stuff have switched over to natural gas because it burns cleaner and it's cheaper to buy. And then, like I said, a lot of the public transportation buses in big cities have switched over to that. And then even industrial, as far as what they can use in those big warehouses, it burns a lot cleaner. So it's better for the people that are working in there on those forklifts and other machines. All right. Natural gas is mainly methane, a strong greenhouse gas. So if some natural gas leaks into the atmosphere from oil and natural gas wells, storage tank pipelines, and processing plants. The U.S. EPA estimates that in 2017, methane emissions from natural gas and petroleum systems and from abandoned oil and natural gas was a source of about 32% of the total U.S. methane emissions and about 4% of the total U.S. greenhouse emissions. Oil and natural gas industry takes steps to prevent natural gas leaks. Okay, and so that's just one thing that they've done. All right. Gas exploration and drilling and production affects the environment. When geologists explore for natural gas deposits on land, they may disturb vegetation and soil with their vehicles. Drilling a natural gas well on land may require clearing and leveling the area around the well site. Well drilling activities produce air pollution and may disturb people, wildlife, and water resources. Laying pipelines that transport natural gas from wells usually requires clearing land to bury the pipe. Natural gas production can also produce large volumes of contaminated water. This water requires proper handling, storage, and treatment so that it does not pollute land and other waters. Natural gas wells and pipelines often have engines to run equipment and compressors, which produce air pollutants and noise. And so, if you look here where it says the water requires proper handling, storage, and treatment, on the way to Hudson or Lander, on the left side of the road there's an evaporation pond, and that's for natural gas. And so they'll go and they'll run these misters, and it'll evaporate just water in the air, and then the stuff that's left over they can clean out and dispose of properly. So that's one of the ways that they're handling and managing that. Okay. Um, there's one out. There's a bunch out by Kinnear. There's a bunch between Casper and Shoshone, so they're all around us. In areas where natural gas is produced at oil wells, but is not economical to transport for sale, or contains high concentrations of hydrogen sulfide, which is a nasty, nasty gas. It's poisonous, so it's sometimes called H2S, and so it's burned or flared at the well sites. Natural gas flaring produces CO2, carbon monoxide, sulfur dioxide, nitrogen oxides, and many other compounds, depending on the chemical composition of the natural gas and how well the natural gas burns in the flare. However, flaring is safer than releasing natural gas into the air and results in lower overall greenhouse gas emissions because the CO2 is not as strong as a greenhouse gas as methane. So, methane by itself, CH4, is worse than CO2. And so, when you burn it, it's actually cleaner and better. And plus, it neutralizes some of the other nasty stuff and makes it not as nasty, although it can create acid rain and some of those other things too. But it's not as bad if you flare it. Okay. Advances in drilling and production technology have positive and negative effects. Okay. New drilling and natural gas recovery technologies significantly reduce the land area that is disturbed to develop oil and natural gas resources, so it's going to be less surface damage. The horizontal and directional drilling techniques make it possible to produce more natural gas from a single well than in the past, so fewer wells are necessary to develop a natural gas field. So there's going to be less space, right? So we have. Ooh, let me get here in front of the camera. So it used to take this much space, and now it takes a lot smaller space, and then there's only like few dots instead of like dots all over the place. And so that's an advantage of what's going on. Okay. Maybe you guys have heard of fracking before. So hydraulic fracturing is what it's called, also called fracking, or freezing. I've never heard it called that. So just fracking is what's most commonly called around here of shale. Sandstone and carbonate rock formations is open up large reserves of natural gas. That's where it's previously too expensive to develop. Fracking involves pumping liquids under high pressure into a well to fracture the rock, which allows the natural gas to escape from the rock. Producing natural gas with this technique has some effects on the environment. Okay, fracturing of wells requires large amount of water. In some areas of the country, significant use of water for fracking may affect aquatic habitats and availability of water for other uses, even well water. So they have to be really careful. Okay, if mismanaged, hydraulic fracking fluid may contain potentially hazardous chemicals. It could be released through spills, leaks, faulty well construction, and other exposure pathways. The release could contaminate surrounding areas. Hydraulic fracturing produces large amounts of wastewater at the surface, which may contain dissolved chemicals and other contaminants that require treatment before disposal or reuse. So basically, it's got some stuff in there that needs to be taken care of before they can release it. And so if it's not taken care of, then it can cause pollution. Okay. The fracturing produces large amounts of wastewater at the surface, which may contain dissolved chemicals of other contaminants that require treatment before disposal or reuse. Because of the quantities of water produced and the complexities inherent in treating some of those wastewater components, per proper treatment and disposal of wastewater is important. Okay, and so complexities inherent, that's a pretty, right here, these two words. And so what it just means is sometimes it's pretty complicated with the chemicals that they use, or some of the stuff that's in the natural gas. So they just got to really be careful, and they have to really stay on top of that, because if they don't, it's going to mess up the water below the surface or the water above the surface. So they got to be careful. Okay. So the USGS hydraulic fracturing causes small earthquakes, but they're almost always too small excuse me, to be a safety concern. In addition to natural gas, fracking fluids and formation waters are returned to the surface. These wastewaters are frequently disposed of by injection into deep wells. So they'll drill these super, super deep wells and they'll just put that bad water down there, and then the natural processes of the water running through the rocks and everything cleaned up. And we'll also talk about injection wells when we talk about geothermal energy as well. So ingestion of wastewater into the subsurface can cause earthquakes that are large enough to be felt and may cause damage. Natural gas could be released into the atmosphere during or after well drilling, and the amount of these releases are under investigation. So there's still stuff we don't know about it, okay? And then the last part, this is pretty interesting, and we talked a little bit about this when we went through the vocab last week, but natural gas production, transportation, distribution, and storage require strict safety regulations and standards. And so, because the natural gas leak could cause an explosion, strict government regulations and industry standards are in place to ensure safe transportation, storage, distribution, and use of natural gas. And so, it's something even as simple as 811. If you've heard of 811, that's the call before you dig. Well, that's a requirement because they don't want you to hit electric lines and stuff like that, but they really don't want you to hit natural gas lines, because if you hit it and you're using a metal bit and what they do is they store the natural gas in those metal pipes as they ship it wherever, and so that's not a good combination. Metal on metal makes sparks. And then this is pretty interesting. This is what we talked about last week. And so, because processed natural gas has no odor, natural gas companies add a strong, rotten, egg-like smell substance called mercaptan to the natural gas so that people can smell the leaks. And so, it's added in to be transported. It's added into even like your barbecue grill. If it's leaking a little bit, you can smell. You're like, ooh, that's nasty smelling. So rotten egg-like, or kind of, we talked about maybe a little bit of skunk-like. And so that's it's added in there for our safety. And they have these cool little instruments and stuff that emit light that can pick up just the tiniest little leaks. Maybe you can't even smell it, but they've done a lot of stuff to keep things safe. So that's good too. All right, here are the questions. What is the most common use of natural gas? Question 1. Question 2, describe each of the sectors of natural gas use. So just talk about electric power, industrial, residential, commercial, and transportation. What are they used for? So you'll just have to go back up to those sections. There's a paragraph, so just summarize that. Why is natural gas considered relatively clean? Okay. And so what would be a good answer here? Natural gas is considered relatively clean because, right? Okay, besides burning, how else does natural gas exploration and drilling affect the environment? What is mercaptan and why is it so important? And then how could natural gas be considered the best fossil fuel? This is, in your opinion, just based off what we've studied over coal, oil, and natural gas today. And so good luck, have fun. It's just good stuff to know, because in Wyoming we have a lot of it, and maybe even some of your family members are involved in that oil, natural gas exploration or development or production even. And so just pretty cool to know, pretty cool to understand. Natural gas is good. We use it all the time. Most of you probably have it in your house. Maybe you cook with it. Maybe you take showers with it. Maybe it heats your house. So pretty good to know about what we use. So hopefully this was helpful. Thank you.